Today we'll discuss about thermodynamics in real gas part 4. So आज का टॉपिक है कंप्रेसर हेड राइज एंड इंथैल्पी राइज एंड दूसरा जो है प्रोसेस टरबाइन इंथैल्पी राइज. Compressor work head rise. Compressor works on gas to increase the discharge pressure from low pressure, and work head or head of compressor is also called work per unit mass. Let's say P1 T1 is inlet pressure temperature and P2 T2 are outlet pressure temperature. So what is criteria? क्या होगा? P2 is greater than P1 and T2 is greater than T1. Generally, three types of head occur in compressor. One is called isothermal head, another is called isentropic head, and third is called polytropic head. However, in the industries, only isentropic and polytropic head are used for compressor design and performance purpose. Isothermal head. The isothermal head or isothermal process, isentropic process, and polytropic process. Isothermal process, when there is a no change in temperature, and this is the minimum head rise which occurs in compressor. But as I said, this is not normally used in the industries. Isothermal process is expressed as P into V is equal to constant because temperature is remain constant. Isentropic process. Process occurs when there is a no change in entropy and process is considered ideal. Isentropic process can expressed as P into V to the power K is constant. Polytropic process is a summation of isentropic process of very small stage of compression and which is expressed as P into V to the power N is constant, where P is pressure in Pascal absolute, V is the volume, K is a specific heat capacity ratio, and N is a polytropic index. Isothermal head. Isothermal head occurs in compressor, which is expressed as below. HI is equal to Z1 into R upon M into T1 into log P2 by P1, where HI is a isothermal head, P1, P2 is inlet outlet pressure, T1 is inlet temperature, Z1 is inlet compressibility factor, M is a molecular weight, and R is universal gas constant. Isentropic head is expressed as HS is equal to Z1 into R upon M into K upon bracket start K minus 1 bracket close into T1 into bracket start P2 by P1 to the power bracket start K minus 1 bracket close upon K minus 1 bracket close, where HS is isentropic head rise, P1 P2 is inlet outlet pressure, T1 is inlet temperature, Z1 is inlet compressibility factor, K is average heat capacity ratio, M is a molecular weight, and R is universal gas constant. Polytropic head rise is expressed as HP is equal to Z1 into R upon M into N upon bracket start N minus 1 bracket close into T1 into bracket start P2 by P1 to the power bracket start N minus 1 bracket close upon N minus 1 bracket close, where polytropic index N is equal to log P2 by P1 upon log RD2 upon RD1, where HP is a polytropic head, P1, P2 is inlet outlet pressure, T1 is inlet temperature, RD1, RD2 are inlet outlet density, Z1 is inlet compressibility factor, N is a polytropic index, M is a molecular weight, and R is universal gas constant. Stagnation polytropic head is HPO is equal to Z1O into R upon M into N upon N bracket start N minus 1 bracket close into T1O into bracket start P2O upon P1O to the power bracket start N minus 1 bracket close upon N minus 1 bracket close, and stagnation polytropic index N is equal to log P2O upon P1O upon log RD2O upon RD1O, where HPO is a stagnation polytropic rise, P1O, P2O is a stagnation inlet outlet pressure, T1O is a stagnation temperature inlet temperature, RD1O, RD2O is inlet outlet stagnation inlet outlet density, Z1O is a stagnation inlet compressibility factor, N is a stagnation polytropic index, M is a molecular weight, R is universal gas constant. Now compressor enthalpy rise. A static enthalpy rise H is equal to CPA into bracket start T2 minus T1 bracket close. And a stagnation enthalpy rise HAO is equal to CPA into bracket start T2 minus T1 bracket close plus 0.5 into bracket start V2 square minus V1 square bracket close, where HA is a static enthalpy rise, HAO is a stagnation enthalpy rise, T1, T2 is inlet outlet temperature, CPA is average specific heat capacity at constant pressure, V1, V2 is inlet outlet velocity. ये हम देख सकते हैं आइसोथर्मल आइसेंट्रोपिक हेड एंड पोलोट्रोपिक हेड वेयर आइसोथर्मल हेड सबसे कम है एंड पोलोट्रोपिक हेड सबसे ज्यादा है. Enthalpy drop in process turbine. As process turbine takes energy from the gas, so enthalpy of gas is reduced and outlet pressure P2 is less than inlet pressure. Also, outlet temperature is less than inlet temperature. The process of expansion is considered as a isentropic process. So, P1, T1 is inlet pressure and temperature, and outlet condition P2, T2 is outlet pressure and temperature. So, criteria for process turbine is P1 is greater than P2 and T1 is greater than T2. Enthalpy drop in process turbine, isentropic and actual enthalpy drop. Isentropic drop HS is equal to H1 minus small h1 minus h small h2s, and actual enthalpy drop HA is equal to small h1 minus h2. If inlet and outlet of turbine is in gaseous state, like in the case when turbine is tested on air, in that case, isentropic enthalpy drop Hs is equal to Cpa into T1 into bracket start 1 minus P2 by P1 to the power bracket start K minus 1 bracket close upon K bracket close. And actual enthalpy drop H is equal to Cpa into bracket start T1 minus T2, where Hs and Ha is isentropic and actual enthalpy drop small h1, h2 and h2s inlet, actual outlet and isentropic outlet enthalpy, T1, T2 is inlet outlet temperature, Cp is average heat capacity at constant pressure, K is the average heat capacity ratio. So thank you for watching.